This lesson covers pages 240 and 241 of our textbook. It would be helpful if you have a calculator. Lesson 2 of Unit 8, Pascal's triangle and binomial expansion. A binomial expansion is taking a binomial and raising it to successive powers. We have an example shown below of the binomial a plus b raised to the power of 0. We know that anything raised to the power of 0 is 1. Then we have a plus b to the first, would be 1a plus 1b. A plus b squared results in the trinomial 1a squared plus 2ab plus 1b squared. A plus b raised to the power of 3 results in these 4 terms. And continuing on, a plus b to the power of 4, these 5 terms. A plus b to the power of 5, 6 terms. Notice that a binomial raised to an nth power has n plus 1 terms. Our binomial raised to the power of 2 had 3 terms. Raised to the power of 3, 4 terms, and so on. Next, we want to look at the coefficients of each term and see if we recognize a pattern. We have 1, 1, 1. The next line we have 1, 2, 1. 1, 3, 3, 1. And we can continue. The pattern is this. If you start with a triangle of ones, so I start with a triangle of ones. Now, bring the 1 down to the outside, and then sum up. 1 plus 1 is 2. Bring the 1s down to the outside, sum up. 1 plus 2 is 3, 2 plus 1 is 3. Bring the 1s down to the outside. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. See how this matches this row here. And bring those ones down to the outside. 1 plus 4 is 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5. Now we're going to use these as the coefficients when we expand a binomial. So the arrangement is known as Pascal's triangle. There is a formula. We are not going to even look at that formula. We want to expand this binomial, m plus 2 raised to the power of 3. We are going to list our terms vertically. So we start with Pascal's triangle from above, the row in which the second number is 3. So we start with this. And vertically we write down 1, 3, 3, 1. Next, we take each term, first the m, and then the 2. Now our exponents on m will start high with the 3 and decrease, 3, 2, 1, 0, and the exponents on 2 will start with 0 and increase. Now we multiply 1 times m to the third times 2 to the 0. That's 1 times m cubed times 1, which is m cubed. 3 times m squared times 2 to the first, which is 2. So this is going to be 6m squared. Next, 3 times m times 2 squared, which is 4. 3 times 4 is 12, 12m. Sorry, this is m squared. 1 times m to the 0 is 1, and 2 to the power of 3 is 8. This is 8. So m plus 2 raised to the power of 3 expands to m cubed plus 6m squared plus 12m plus 8. So the result is these 4 terms. More practice on the next page. In the upper right hand corner, let's start Pascal's triangle again. So we start with three ones in the form of a triangle. Bring down the ones to the outside. Add 1 plus 1 is 2. Bring down the ones to the outside. 1 plus 2 is 3. 2 plus 1 is 3. Bring down the ones to the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Bring down the ones to the outside. 1 plus 4 is 5. 4 plus 6, 10. 10, 5. And I see down here, number 4 at the bottom, we're raising 3x minus I to the power of 6, so one more line. 6, 15, 20, 15, 6. Expanding a minus 3 to the power of 4, we go to the line, or the row in our Pascal's triangle where the second digit is a 4. So 1, 4, 6, 4, 1. The first term of a binomial, the second term is negative 3. For the first term, our power starts with 4 and decreases. For the second term, the negative 3, it starts at 0 and increases. 1 times a to the 4th times negative 3 to the 0 is 1. So that's 1 times a to the 4th times 1, which is a to the 4th. 4 times a to the 3rd times negative 3 to the 1st is negative 3. 4 times negative 3, negative 12. Negative 12, a to the 3rd. 6 times a squared times negative 3 squared is 9. And 6 times 9 is 54. 4 times a times negative 3 to the power of 3 is negative 27. And we're multiplying. And 4 times negative 27 is negative 108. So negative 108a. And our last term, 1 times a to the 0 is 1. Negative 3 to the power of 4 is 81, positive. Now let's write our 5 terms. A to the 4th minus 12a to the 3rd plus 54a squared minus 108a plus 81. So a minus 3 to the power of 4 expands to this expression. Expand the binomial 2x plus 3y raised to the power of 5. Go to this row of Pascal's triangle. We'll have 6 terms. 1, 5, 10, 10, 5, 1. Take our 2x. Our exponents on 2x start high with 5 and decrease. 4, 3, 2, 1, 0. 3y. Exponents start with 0 and increase. Alright, so this is where I'm just going to put into the calculator 3 to the x and have the table of values. So I have the table of values keyed up for me. One times 2x to the fifth. Okay, 2x to the fifth. Well, 2 to the fifth is 32. So this is going to be 1 times 32 x to the fifth. 3y to the 0 is 1. This is equal to 32 x to the fifth. 5 times 2 to the fourth is 16. So this is 16 x to the fourth times 3y. 5 times 16, I believe, is 80. Times 3 is going to be 240. So this is 240 x to the fourth y. Next, 10 times 2 to the third is 2 times 2 times 2, which is 8. Times 8x to the third, sorry. 3y squared is 9y squared. Okay, so I would do 8 times 9 is 72, times 10 is 720. So we have 720 x to the third y squared. Next, 10 times 2x squared is 4x squared. And 3y cubed is 27y to the power of 3. 4 times 27 was that 108 times 10 is 1080 x squared y to the third. 5 times 2x to the first is 2x, and 3y to the power of 4, 3 to the fourth is 81, y to the fourth, and that's 10 times 81 is 810, xy to the fourth. And 1 times 2x is 0 is 1, and 3 to the fifth is 243 times 243 y to the fifth, which is equal to 243 y to the fifth. Alright, so 2x plus 3y raised to the power of 5 expands to these 6 terms. 32x to the fifth plus 240x to the fourth y plus 720x to the third y squared plus 1080 x squared y to the third plus 810 xy to the fourth plus 243 y to the fifth. And the last one. You could try it on your own if you like. We're expanding to the power of 6. Writing down this. 1, 6, 15, 20, 15, 6, 1. 3x. Start exponent 6, 5, 3, 2, 1. Whoops, missed one. 5, 4, 3, 2, 1, 0. And this is negative I, our imaginary number I. It takes a bit of time just to write the terms down here. 0, 1, 2, 3, 4, 5, 6. Alright, here we go. 3x to the 6th. Still have that here. That's 729. So this is 1 times 729, x to the 6th, and negative I to the 0 is 1. So 729, x to the 6th. Next, 6 times 3 to the 5th is 243. 243, x to the 5th, this would be times negative I. And 6 times 243 times the negative 1, or the negative from the I, is going to be negative, let's see, 6 times 3 is 18, 6 times 4 is 24, plus 1 is 25, and 6 times 2 is 12, plus the 2 is 14. So negative 1,458 x to the 5th I. This is 3x to the 4th, so that's going to be 15 times 3 to the 4th is 81, x to the 4th, and negative I squared is simply going to be I squared, which we know is equivalent to negative 1. Alright, so we have 15 times 81. $12.15. So negative 12.15 x to the 4th. This is 3x to the 3rd, so that's 27. So 20 times 27 x to the 3rd, negative I to the 3rd is the same as negative I to the 3rd. And I to the 3rd is equivalent to negative I. So that would end up being a negative I would be positive I. Okay, so 20 times 27, well, 2 times 27 is 554, so 540. Negative is positive, so positive 540 x to the 3rd I. $15 times 3x squared is 9x squared, and negative I to the power of 4 is going to be I to the 4th, which is equivalent to I to the 0, which is 1. 9 times 15, 135. Six times 3x times negative I to the 5th is the same as negative I to the 5th. I to the 5th is equivalent to I so this is 18x times negative I, which would be negative 18xi. And our last one, 1 times 1 times a negative I to the power of 6 is going to be positive I to the 6. And I to the 6 is equivalent to I squared, which is equivalent to negative 1. So here we have our 7 terms, 729 x to the 6th minus 1,458 x to the 5th I minus 1,215 x to the 4th plus 540 x to the 3rd I plus 135 x squared minus 18xi minus 1. There you have it. Thank you for your patience with that one.